In this video, we'll try to understand how to solve examples on properties of steam using steam table. So this question we have taken from Thermodynamics question paper, Pune University, and the question number is 3B. Here we have to find out the enthalpy of 1 kg of steam at 12 bar pressure when the conditions, various conditions they are given. The first condition is saturated liquid condition. Second one, when the steam is dry saturated. The third one, when the steam is 22% dry. Next condition is steam is 50% dry. Then steam is superheated to 250 degree centigrade, and last condition is it is subcooled to 100 degree centigrade, and the specific heat of superheated steam is given as 2.25 kilojoule per kg Kelvin. So the data which is given over here is mass is 1 kg, so we have to find out the specific enthalpy. Pressure is 12 bar and Cp of superheated steam is 2.25 kilojoule per kg Kelvin, and we have to find out the specific enthalpy for the various cases. Now the first condition is saturated liquid condition. Now we know that in case of the saturated liquid we have to consider only the sensible heat, so it is nothing but HF at 12 bar. So the value of HF at 12 bar, so this is the 12 bar pressure, and the value of specific enthalpy of water, saturated water, that is HF, is 798.4 kilojoule per kg. So that is our first answer. In the second case, the steam is dry saturated, that is it is consisting of sensible heat as well as the latent heat, and the addition of HF and HFG is nothing but Hg. So we have to note down the value of Hg at 12 bar. So this is 12 bar and the Hg is 2782.7. So it is 2782.7 kilojoule per kg. The next condition is that steam is 22% dry. It indicates that it is a wet steam having dryness fraction of 0.22, and the enthalpy, specific enthalpy of wet steam is given by HF plus X HFG, where HF is the specific enthalpy of water or sensible heat part, and HFG is the specific enthalpy of evaporation or latent heat part, and the value of X is given as 0.22. So substitute the value of HF. So HF is 798.4 at 12 bar as we have already seen. Then X is 0.22 and HFG the value is 1984.3. So the given particular enthalpy, specific enthalpy of wet steam is 1234.946 kilojoule per kg. The next condition is steam is 50% dry. It also means that it is a wet steam. The steam is 50% dry, means it consists of it is 50% dry and consisting of 50% of water particles in suspension. So as it is a wet steam, again we have to use the same formula, that is H wet is equal to HF plus X HFG, and at 12 bar from the pressure basis steam table we know the values. HF is 798.4, X is 0.5 and HFG is 1984.3. So these are the values which we have taken from this particular steam table, and the value of H wet is 1790.55 kilojoule per kg for this particular case. Now for the next case where the steam is superheated, we will require this value of the saturation temperature. So Ts is a saturation temperature, and that value at 12 bar pressure is 188 degree centigrade. So when the steam is superheated to 250 degree centigrade, so value of T sup is given as 250 and saturation temperature is 188, just now we have seen. Cp of superheated steam is 2.25 and Hg is 2782.7. So these values we have taken at 12 bar from pressure basis steam table. So H superheated is equal to Hg, that is the specific enthalpy of dry saturated steam, plus the heat of superheat, that is mass into Cp into delta T. Mass we have taken as 1, so it is not written over here. So Hg is 2782.7, Cp is given in the example, T sup is 250 and saturation temperature is 188 at 12 bar. So the calculation will give the value of superheated, specific enthalpy of superheated steam as 2922.2 kilojoule per kg. So in the next case the steam is subcooled to 100 degree centigrade. So H is equal to HF, because on the subcooling line it is a saturated liquid, so it is HF at 100 degree centigrade. So from the steam table at 100 degree centigrade HF is 419, so that value is 419 kilojoule per kg from temperature basis steam table. So here it is a temperature basis steam table. So in this way we can find out the properties of steam, that is in this particular case it is the specific enthalpy using the steam table. Thank you very much for watching.